All right, here we're going to look at the Unit 1 test review, and we're going to go through the solutions one at a time, and I'll explain the methodology behind them. So number 1, identify the translation of the parent function f of x equals x squared that give g of x equals 3 times x plus 2 squared minus 1. What we want to look at here is a, h, and k. So we have something like f of x is equal to a x minus h squared plus k. So for a, I'm going to write everything out here and then I'll write the answers. When a is greater than 1, there is a stretch. So the absolute value of a is greater than 1. When the absolute value of a is between 0 and 1, there is a compression. So we have that here. And then for h and k values, if we are subtracting h, that moves right. If we're adding h, that is going to move left. Plus k moves up, and minus k moves down. Okay, so let's actually go through this one, make this a little larger so we see better. All right, so the 3, right? We have this 3 here. That is greater than 1, so that tells me there is a stretch. So my actual answers, there's a stretch by a factor of 3. Next I have this plus 2. That's going to be here. So that tells me that there is a shift left 2 units. And then finally I have this minus 1, which tells me that's minus k, which means there is a shift down 1 unit. There's also the possibility of a reflection. That doesn't happen in this one, but if a is negative, there's a reflection, and I'm not going to go into too much detail, mostly because it doesn't happen on the test, so you don't have to worry about it. But if a is negative, there would be a reflection over the x-axis. All right, moving right along. Number 2, we want to graph the function, and in this case it's a piecewise function. So we're going to deal with these one at a time. We need to worry about open and closed circles and all that fun stuff. All right, so for this example, this first one, these values here, this negative 3 and this negative 1, are my x values. So I'm going to do negative 2 times negative 3 plus 1. I get 6 plus 1, which is 7. All right, so that tells me I used negative 3, so I have the point negative 3, 7. I'm going to do the same thing with the negative 1. So I have negative 2 times negative 1 plus 1. That's going to give me 2 plus 1, which is 3. So I have the point negative 1, 3. So remember that this negative 3 and that negative 1 are the x values. They came from that first line. So that is my x, and then let's try not to run out of colors here, but this 7 comes from there, this 3 comes from there. Now you need to decide whether open or closed circles. Open or closed circles are dependent on these symbols here, these inequality symbols. That first one, that is going to be an open circle. The second one's going to be closed. So make a little note. Open, again, because it's just less than. This one is equal to, less than or equal to, so this is going to be a closed circle. So at negative 3, 7, negative 3, 7 is going to be up here. I'm going to put an open circle. Negative 1, 3, I'm going to put a closed circle. And then play connect the dots. All right, I want to do the same thing for the next one. So I'm going to use negative 1 and 2. Those are going to be my x values. So negative 1 minus 2, that's going to be negative 3. So negative 1, negative 3. And then 2 minus 2, which is 0. So 2, 0 is going to be my point. So we plugged in negative 1, we plugged in a 2. Let me actually put those in parentheses so we remind ourselves. So negative 1, 2. And then the same thing. When we solve that, that negative 3 came from there, that 0 came from there. In this case, if I'm looking here, they're both less than, so that tells me that they are both open circles. So at negative 1, negative 3, negative 1, negative 3 is going to be an open circle here, and 2, 0, open circle right there, and again, connect the dots. All right, now the final one. We have 2 and 5. Those are my x values. All right, there is no x value to plug in. So what that means is that no matter what I plug in as x, y is always going to be 2. All right, so these two numbers, the 2 and the 5, those are my x values. This 2 is always going to be the y value. So that's where that comes from. Here we would have a closed circle because that 2 has that less than or equal to, and the 2, 5 is going to be an open circle. So 2, 2 is going to be right here. Oh, sorry, closed. Let's fill that in. 2, 2 is closed. And 2, 5 is open. Oh, I wrote the numbers backwards. Gotta fix that. Sorry about that. My x values are 2 and 5. I copied my own work wrong. And then the y value is 2 and 2. So that goes with the purple highlighting, and those 2 and 5 come from the green. I said the right thing, I wrote the wrong value. All right, so 2, 2, which is good, and 5, 2 would be here, and that's going to be an open circle. All right, so for these, just take the values, whatever is here, these values get plugged in as your x values, and then find your points. Make sure you're careful with your open and closed circles, and if you do that, you should be okay. All right, 3 and 4. Number 3, use a graph to solve. So this one, we're going to use our calculator over here. So I'm going to go to my calculator and my y equals. I'm going to put the first half as y1, so that's going to be the absolute value. Math, go to number, select the absolute value. So x minus 1. Outside the absolute value, I want plus 2. I'm going to go down to y2. So I'm going to put a parentheses, x minus 1, close my parentheses, and square that. All right, so just make sure they're typed in correctly, which in this case they are. If I hit graph, I get a graph that looks like this. It looks like the solutions are going to be somewhere around -1 and 3. So let's go to our table so we can actually graph this, and then we'll go from there. So my graph stays with 5, so all right. Let's go with -2, 5. So -2, 5, I'm going to have a point up here. Then -1, 4. 0, 3. So these are the points from the absolute value one. So 0, 3, 1, 2, 2, 3, 3, 4. You wouldn't need every one of these points. I'm putting them all in just to do all of it so that there's nothing missing and there's no confusion. Should have my absolute value look something like that. Now my parabola, so I'm going to use the red values here on my calculator. So I have -2, 9, which is off of my chart, so I'm not going to use that. -1, 4, so we'll start with that. That matches up, so that's going to be a solution. 0, 1, 1, 0, 2, 1, and 3, 4. And then the next one is off the graph. So my parabola will look something like this. Not my best work, but it's good enough. And then my solutions are where they intersect. So they're going to intersect right here. And I want the x values for those solutions. So the x values are x equals, let's write it up here, x equals -1, x equals 3. So you type them into the graphing calculator, use your table to get the points, and then find the intersection points, and you have your solutions. All right, number 4, use a graph to solve. So I'm going to go back to my y equals, and I'm going to clear these out. So I'm going to go back to my y1, type this in. So not the most user-friendly absolute value function here, but let's go with it. So 3, remember the math, scroll over to number, select the absolute value, x minus 2, leave the absolute value, subtract 3, make sure you're using a subtraction sign, not a negative sign, and we're good. We don't have to type in the greater than or less than, the greater than or equal to 0. We're just going to type that. Hit graph. All right, I get something that looks like this. I want the actual values, so I'm going to go to my table. Again, we're staying in the ranges of 5, so the first number I see that's going to work for me is 0, 3. So that'll be right here. 1, 0. 2, negative 3. 3, 0. So now we're going back. We found our vertex, which is good. And 4, 3. So that's going to be right here. All right, so a pretty sharp curve here. Try and straighten out this line. Make these lines as straight as we can. There we go. All right, so this is an absolute value, so this is going to keep going forever. Now, what's important to note is that I want the values that are greater than 0. 0 being basically my x-axis, so I want the values that are above the x-axis. So I'm looking for everything that is going to be above the x-axis here. And for this specific problem, that is going to be this piece here, right? I want this portion. And to turn my screen around so I don't hit the calculator, and this portion here. All right, so these are the two pieces that I want. They are greater than 0. That's where the graph is greater than 0. So the left portion, so let's say this one here, what we have there is that x is going to be less than 1 because I want the values to the left of 1. So x is less than 1. And the 3, so this point here and this point here, we want the values that are to the right of 3, so that tells me that x is going to be greater than 3. All right, so x is less than 1, or x is greater than 3. So let's get rid of that. We'll just write those in there. All right, that's it for 4. Greater than is above the x-axis, less than would be below the x-axis. This is a greater than, so we want the values above. All right, number 5. I'm actually going to go back to 5 at the end because I'm going to show a couple ways to do that. I'm going to go to number 6. Or no, because the video you'll scroll. I'll do number 5. So solve this system of equations. There's a couple ways to do this. I'm going to start with substitution, but I will also show the elimination method. So you can choose which one of these you want to use. Don't use both of them. Pick one or the other. All right, substitution. I have x plus 2y equals 8. I need an equation that is isolated, a variable that is isolated. So I'm going to subtract 2y. X is equal to 8 minus 2y. I can now take that x value, and anywhere there's an x value, I can replace it with 8 minus 2y. So I'm going to do that in the second equation. So it's going to become 4 times 8 minus 2y minus 2y equals 2. And now we solve for y. So we get 32 minus 8y minus 10y equals 2. Be very careful here. It's negative 8 minus 2, so that's negative 10y. I'm going to subtract 32. Again, be careful. Don't rush through that. Keep that negative 10 with the y, or the negative with the 10 and the y. 2 minus 32 is negative 30. I then divide by negative 10, and that means y is equal to 3. so it's the first part of my solution. From there, I'm then going to take that y equals 3, and I can plug that in wherever I want. Let me just highlight that. So that y equals, that's not what I'm trying to do. That y equals 3. Anywhere there's a y, I can plug in. So I can use the first equation, the second equation, or I can actually use this equation here to find x. So I'm going to do that. I'm going to say x is equal to 8 minus 2 times 3. I'm going to use this equation because x is already isolated. So x equals 8 minus 6, which means x is equal to 2. Again, that is part of my solution. So my final solution would be 2, 3. Now, let's say I wanted to use the elimination method. This problem, the elimination method, was actually easier. So I'm going to write my two not inequalities, it's from the previous video, my two equations, and I'm actually going to add them up. So this is a 1x. 1x plus 4x is 5x. 2 plus negative 2 cancels out. 8 plus 2 is 10. So this becomes a very easy problem to solve. X would be equal to 2. I can then take that x value and throw it back into one of my equations. I have x plus 2y, so I'm going to replace x with 2. This equals 8. So 2 plus 2y equals 8. Subtract 2. 2y equals 6. Divide by 2. Y is equal to 3. So it's good that I got the same answer using both methods. That means I either did this wrong twice or I am correct. So here, you can choose the substitution method, you can choose the elimination method. In this problem, elimination was probably a little bit easier because they were matched up pretty well. If you don't have the variables matched up, then elimination could be more work, but choose your method. It's up to you which one you use. You could also use the graphing method. So I could have done what we did with number 3. It's going to be way more work, especially in this case, because y is not isolated, which means it's not going to be very easy to enter into the calculator, but it is possible. All right, number 6, write a matrix that represents the system of equations. These ones are easy. Everyone enjoys these because there's not a whole lot of work. Just make sure that it's x then y and then the equal to a constant, which it is. So I'm just going to copy my coefficients, 8, -9, -1, and 10. So these numbers here went here, and these numbers went here. That's it. They just want you to write the matrix that represents the system. They're not asking you for anything else, so you did your job. Finally, number 7, what is the reduced row echelon form for the matrix shown? All right, now we're going to go back to our calculators. We're going to go second, x1, x to the -1, I always say that, x to the negative first, which is the matrix. I'm going to scroll over to where we want to edit our matrix. So we have 3 rows, 4 columns. This is going to be a 3 by 4 matrix. So 3 rows, 4 columns. And now I'm just going to type everything in. So -2, 2, 1, 14. Try that again. 14, 3, -2, 1, -5, -1, 1, -2, and -8. So always check your matrix, make sure that you did it correctly, and to do that very easily, you hit second, matrix, enter twice, and then make sure this matches up. All right, so everything matches up, so we're good there. Now we're going to go to second matrix, go to math, and we want the reduced row echelon form. So option B, select that, go to our matrix one more time, select matrix A, which is what we edited, close the parentheses and hit enter. So now we're going to copy this. This is the reduced row echelon form. So it's always going to be 1, well, not always, but for our purposes, these are the numbers that we get. Get -3, 1, and 6, which means that x equals -3, y equals 1, and z equals 6. They didn't ask us for the x, y, and z values, but it's always good to know what they are. They only want to reduce row echelon form, so we could have stopped with that. All right, and that is it for the test review. Hopefully you know what you're doing.